Welcome to the Mahatma Gandhi Institute of Technical Education and Research Center. In 2004, a national level institute MGITER has been started in the field of engineering and technology as per guidelines of All India Council for Technical Education AICTE New Delhi. MGITER is approved by AICTE New Delhi, Gujarat State and affiliated to Gujarat Technological University Ahmedabad, which is also known as GTU. Our goal is to be an institute of generative ideas so that we remain relevant to our society. The MGITER has always been an organization on move with continuous effort on improving its processes and to maintain its relevance to the Indian science scenario, with adding new programs in its programmatic portfolio. We strongly believe in overall development of students, so for that we provide them a different platform like state level tech fest, project fair, different sports activity, which helps students to teach teamwork and problem solving skills to get physical health benefits, boost self esteem, and reduce pressure and stress for prove their skills in distinct area. Welcome to the virtual class of Power System Transients. Myself, Professor Gaurang Patel from Mahatma Gandhi Institute of Technological University Research Center, NAVSARI. In last video lecture, we were discussing regarding the traveling waves on transmission line. Okay, so in last lecture we were discussing about what is the traveling wave, what is the basic fundamentals and basic phenomena of traveling waves. Okay, and in this lecture we will see about the introduction of traveling waves, and then we will move towards the circuit with distributed constant, and we'll see the wave equation when transmission line is short circuited and transmission line is open circuited. What are the equations we can be found over there? Then we will see the reflection. Just a moment. Then we will see the reflection and refraction of traveling waves, and then be insulation coordination as well as behavior of traveling waves at line transmission line. So I hope in last video lecture you know basically what is the traveling wave and what is the fundamentals behind that. Okay, till I would like to discuss some of the things which is important regarding the traveling wave. There is the definition of traveling wave, which says that it is a temporary wave that creates a disturbance and move along the transmission line at a constant speed. Okay, and such type of wave occurs for a short duration, that we all know, that is the traveling wave which is occurred for a short duration. Okay, uh, in last lecture we see that these are the basic block diagram of transmission line that we assume over here, that when we close the switch initially, at we discussed that when we close the switch initially, the voltage and current that is not reached instantaneously at the output side, but it will take some time. Why it will take some time? Because there is a charging of capacitor and charging of inductor which is inherently present in the transmission line. That's why it will take some time to reach their destination. Okay, and in between that, whatever the wave is created, that is known as the traveling wave. That what we discussed in the last video lecture. Okay, so over here I would like to start with this, that is this one. We can see that, as we know, on the basis of distance there are three types of transmission lines are there. Okay, there is one short transmission line, medium transmission line, and long transmission line. Okay, and this transmission line, that is, it is has the combination of distributed parameters. Okay, which is distributed parameters, that means the per unit length of the particular line, which we can be considered as a L1, and capacitance we can be taken per unit length as a C1. Okay, so over here R, L, C, that those are our distributed parameters. Okay, so here we can see that there is a source side and there is a load side, and in between that there is a transmission line. So it says that immediately transmission of power from source to load, but it will not happen exactly. And why it will not happen, that we have already seen in the fundamentals of for traveling wave. So today what we are going to explain, or what we are going to show and interested, that is to form the equation when the transmission line is open circuited and transmission line is short circuited. Okay, so I will show you one by one over here in the form of equation. Okay, now here I draw one transmission line having, we assume that is it is having a distributed parameter, that is L1, L2, Lm and C1, C2, Cn, at the end of the line there is a load. Okay, so as we discuss about the traveling wave, okay, there is a source side that we denoted as a V, there is positive sign and there is the negative sign. Okay, so when switch S is on initially, so what is the phenomenon of traveling wave, says that power is not going directly towards the load. And why it is so? Because there is an inherent inductance and capacitance in each and every section of the transmission line, and that what we already shown over here. There is an inherent inductance, you can see over here L1, and inherent capacitance over here. Okay, so when you switch on the supply, when this switch S is initially n, at that time the inductor is charged. Okay, at that time that inductor is charged with the value of 1.5. This inductor is charged with the value of 1.5 Li square. Okay, and similarly this capacitor is charged with that approximate value of 1.5 CV square. Okay, so first of all, just a moment. So as we can see that when switch S is on, that L is charged with 1.5 Li square and C capacitor is charged with 1.5 CV square. So when it was fully charged, then this power is transmitted to the another section, and similarly at that time L2 will be charged with 1.5 Li square and C2 will be charged at 1.5 CV square. So this phenomenon is going on, that's why this power is interrupted and it will not going immediately to the load. Okay, so now we will form some of the equation regarding that. And when this phenomenon is happen, what happens, some of the power will be reflected and some of the power is going to be refracted. Please remember and keep in mind that reflected and refracted both terms are the different, as this is one term is known as reflected and one is refracted. Okay, both the term are different. How it will different, I will show you in this explanation. Just a moment. Now we will try to plot this value in that graphical manner. Okay, suppose this is the graph we are drawing over here. Okay, this will be the incidence value of voltage and current, okay, at the overhead line. Okay, so when this voltage and current is incident at that particular point, so each and every power or amount of each and every power will not be reach up to the destination at the end. At the end we will consider, or we will denote, that is the V2 and I2. Okay, that is the receiving end voltage and receiving end current. Suppose we consider this is the sending end voltage and sending end current. So what happened at that point of center, some of the power will going to be reflected. This we known as reflected. Okay, please keep in mind those things and try to understand very carefully, because there is so many times it will asked in examination, and it's also so many times asked in viva examination as well. What is the reflected wave and what is the refracted wave? So this is the reflected wave. So this amount of voltage and current we will denote as a V1 and I1. Okay, V1 and I1. Okay, this V and I, that is the incidence current and voltage, that is the reflected current and voltage, and the amount of voltage and current that is reached up till up to this end, amount of voltage and current that is reached up till this end, that is known as V2 and I2, and that is known as refraction. That is known as refraction amount of voltage and current, and the refraction amount of voltage and current that is equal to V2 I2, that is equal to V2 I2, that is equal to incidence voltage and incident current plus reflected voltage and reflected current. Okay, so I hope you I hope you understood this phenomenon very carefully. If we plotted in this in graphical manner, we can see that that is the voltage and current at the incidence. So due to the charging of one and half, due to the charge at the time of charging, we know that there is inherent charging capacity, that is for inductor 1 and half Li square, and for capacitor that is 1 and half CV square. Okay, that's why some of the voltage and current is going to be reflected at that particular point. Okay, and some of the voltage and current, then it is going to be reach the destination, and that is known as a refraction. Okay, so V2 and I2, that is denoted as the refraction, and total refraction power, that is equal to incidence voltage and current plus reflected voltage and current. So I hope now you clear in your mind that what is reflection and what is refraction. Okay, both are the different terms, and how it will be affected, that you understood very well by this explanation. Okay, so over here in this circuit you can see that there is a distributed parameter L and C over there. So once again I would like to explain you that is what is the distributed parameters. Okay, so distributed parameters, that means for per unit, just a moment. Okay, so the distributed parameters, that means the per unit length, at for the per unit length value of inductance is L1. Okay, per unit length value of inductance is we can consider as a L1 for the per unit length, and value of capacitance for per unit length we can consider as C1. So it why we need to be assumed as an distributed parameters, it is because of the easy calculation, because these by assuming this per unit length parameter, we can consider that each and every section, that means there are a different section which is having inductor and capacitor. Okay, so it's all section having the same amount of inductance and capacitance that we are assumed. So that will help you for the betterment or simplification of the calculation. Okay, so that is the distributed parameters. Once again, it is distributed parameter means for per unit length value of inductance is L1 and value of capacitance, that is C1. Okay, now when switch is on, inductor is behave as an open circuit and capacitor is behave as a short circuit. Okay, that is also very important things. When initially when switch is going to be on, that your inductor L is behaving as a open circuit and the capacitor that is behaving as a short circuit. Okay, so next we will. Okay, now here if I take the ratio of voltage and current, then what happens, that we will see. If I take the ratio of voltage and current, that means ratio of voltage and current. If I take the ratio of voltage and current, that it we can write root L by C, that is inductance upon capacitance, and which is also known as Zn. Okay, Zn is nothing but the surge impedance of line. Zn is nothing but the surge impedance of line. Okay, and one more thing I would like to tell you, that if I take the ratio of V and I, then the value is as this root L by C, and that what we consider as an Zn, which is known as surge impedance of line. And this surge impedance does not have any relation with the load side. Okay, that means it is not dependent on the load impedance. Okay, that it's also suggests that it's only depends on inductance and capacitance of the line. Okay, so when you take the ratio of voltage and current, you will get the surge impedance of line, and this surge impedance of line that not depends on the load impedance. That surge impedance does not depend on the load impedance. Okay, this is also a very important statement. Okay, so the surge, and from that we can say that the surge impedance is only depends on the capacitance and inductance of the line for that particular line. Okay, so now next we will see that what is the value which is taking of the surge impedance and the line impedance. Suppose there is a transmission line is given, so there is a fixed value for the surge impedance for the overhead line, that is we consider for the overhead line, the value that is considered for the 400 Henry per meter, and for 400 ohm, and for underground line this value is considered as a 40 ohm. I am talking about the value of surge impedance. So value of surge impedance for overhead line, that is 400 ohm we are going to take, and for underground line, that is we are taking for this value, that is 40 ohm. Okay, so if you understood that the things from what is surge impedance of line, and then we can move towards the velocity of propagation of the wave. Okay, we move toward the velocity of propagation of wave. Okay, so let's see what this will contain, that is velocity of propagation of wave. If you consider, that is v is equal to 1 upon root LC, okay, is equal to 3 into 10 raised to 8 meter per second. That's generally we are taking, that is velocity of propagation, that is v is equal to 1 upon root LC is equal to 3 into 10 raised to 8 meter per second. Okay, so but when it is considered, okay, and how it is considered, that we will see. We can consider this value for the propagation only when we consider the internal resistance is negligible. Remember this term, when you consider the internal resistance, the internal resistance is negligible, then and then you can consider the propagation or velocity of propagation v is equal to 3 into 10 raised to meter per second. Okay, but in actual case, if we consider all the parameters as it is, if we are not consider that internal resistance is not negligible, then the actual value of v that we have to consider with v is equal to 2.5 into 10 raised to 8 meter per second. Okay, so these are the two things we can consider for the propagation of velocity. If you consider negligible resistance, that at that time you can move or go with this value 3 into 10 raised to 8 meter per second. And if you consider the each and every parameter, and if you want to go with the actual value, that you have to consider 2.5 into 10 raised to 8 meter per second. Okay, so in today lecture session, we understood the phenomenon about the traveling wave and what is the behavior of the traveling wave on the transmission line. We saw that how the distributed parameter L and C going to be affected when supply is on. Then we see the very important parameter, that is refraction and reflection, through this graphical manner. And then we see, that is when we taking the ratio of voltage and current, then how the surge impedance come into the picture, and what is the value of the surge impedance in the case of overhead line and in the case of underground line. And then we also seen that velocity of propagation of traveling wave, that is also having the two distinct parameters. When you consider the internal resistance is negligible, then which value you have to taken, and when you going with the actual value, then what value you have to consider at the time of calculation. Okay, so I hope you understood this up to this. In next video lecture, what we have to see, we have to see that what is the value of voltage and current at the open-ended transmission line and at the short-circuited transmission line. So what is the equation for voltage and current for both of the case, that we will see in the next video lecture section. Okay, and I would like to also show you, that is the how this forward and backward nature of traveling waves, that affects the transmission line. And also in this diagram you can see there is, just a moment, okay, so there is the phenomenon of refraction and reflection, what we understood with that graphical manner. It is also denoted by the Beverly lattice diagram as well. You can see when the switch is on, this wave is going to be reflected from over here. Some of the wave is coming back and some of the wave is going reach to the destination. So this wave which is reflected back, that is known the reflection, and this wave, that is the wave that is known as a refraction wave, which we can be determined from the Beverly lattice diagram. Okay, so those are the things that we have to understand in this lecture session. So as I told you that in next lecture session we will discuss with the open-ended and short open-ended line and short-circuited line with the equation of voltage and current. Okay, so as we going through each and every video lecture session, we were going through the question asked in GTU. So what are the what kind of question was asked in GTU? So it can be helpful to you or benefited to you when you are preparing the examination. You can see in GTU examination they are asked for the explanation, they are asked for the explanation for reflection and refraction of traveling waves, okay, by considering voltage and current waves. And also they ask that write down the expression for reflection coefficient and refraction coefficient. Okay, so I hope you able to derive those equation and you able to understand how you can derive those equations. Okay, so in this video lecture we are discussing these many things. In next video lecture session we will going further in the chapter traveling wave. Okay, thank you.